Alright, in this problem we're starting with a slightly different question. The first question asks us to find the mass percent of acetylsalicylic acid. I'm going to abbreviate that from now on as ASA, so just keep that in mind. Alright, so to find the percent by mass, the percent will equal the mass of ASA divided by the mass of the aspirin tablet, and that will be times 100. So in this case, the mass of the aspirin, which is given to us, and we're going to change it to grams so both of them are the same unit, is going to be 0.325 grams divided by 2 grams times 100, and that's going to equal 16.3%, and that's the answer to question A. So that was pretty straightforward. Now question B, it tells us how much of several chemicals are produced when we burn the acetylsalicylic acid. So first thing we're going to do is to find out how many grams of hydrogen they have. So if we do the hydrogen first, we're going to use the fact that there is 1.2 grams of water produced. So if I have 1.2 grams of H2O, I know from the formula that for every 18.02 grams of water, there will be 2.02 grams of hydrogen, and those two numbers come from the periodic table. So if I multiply those two out, I get 0.134 grams of hydrogen. So first element is now done. Now we'll go to the second element. The second element we'll conquer is going to be carbon dioxide, so that's CO2. And in this case, they give us some gas laws. So we're going to have to find grams in the ideal gas law. So PV/mm equals GRT. The pressure that we're under is 750. The volume that we're given is 3.72. The molecular mass of carbon, carbon dioxide, adding it off the chart, is 44. The number of grams, which is what we're looking for, R has to correspond to millimeters of mercury, so it'll be 62.39, and the temperature has been given as 25, adding 273 gives me 298, and we solve that for G. So when we get that done in our calculator, we will get G as being 1.801 grams. So we have two of them down. Now the last one we need to find is the amount of oxygen. So now to do this, we know the total amount is 3.00 grams. So if I take these other two and I subtract them from that, I should get whatever is left over, which will be the oxygen. So I'm going to subtract 0.134 plus 1.801, and I'm going to get the amount of oxygen that's left, which will be 1.6. Oh, try that again. Eraser. 1.065 grams. So there's my three masses, which is what I was looking for. Alright, moving on. We got some space over here, so let's use it. Let's do C over here. So we're going to dissolve a given amount of ASA in water, and then we're going to titrate it to the equivalence point. So first off, what we're going to do is to find how much sodium hydroxide we're going to be using to titrate this. So we will start with 0.08843 liters of the solution, which has a concentration of 0.102 moles per liter. And if we multiply that out, we will get 0.00902. And that will be moles of ASA, because it's also equal to, since it's a titration, and at the end point it has got to equal, it also equals the moles of NaOH. So those two things are equal. Now, what we're going to do is we're going to find the molecular mass. So we know, or we should know, that molecular mass is equal to grams divided by moles. Well, the grams are given to us as 1.625, and the number of moles we just found, 0.00902, and if we divide that out, we get 180 grams per mole. And that is our answer to C. Alright, next page, and we'll move on to D. Alright, so on D, we're asked to find the Ka of the ASA. And we're going to find that by doing the concentrations. We do know the equation for the ionization for that, so we'll get the Ka will equal the concentration of the H plus times the concentration of the ASA minus over the concentration of the ASA. Alright, so they give us the pH, so we'll use that. So pH equals 2.22. So we can find the concentration of H plus, because we know that 10 to the minus pH power is equal to the H plus concentration. So this will be 10 to the minus 2.22 power, which comes out to be 6.03 times 10 to the minus third power. So we go back over here. We're going to take this value and we're going to put it in right there. So the Ka will equal 6.03 times 10 to the minus third, and that's going to be equal to both of the terms on top, so we'll square that, divided by the concentration of the aspirin, which we have to find. So we'll take that concentration of the aspirin over here and we'll find the concentration of the ASA. And it tells us that we put in 2 times 10 to the minus third moles in 15 milliliters, which is 0.015 liters, and that will give me a molarity of 0.133. Again, I will use that value over here, so 0.133, and I solve that for Ka, and the Ka comes out to be 2.73 times 10 to the minus fourth, and that's our final answer. You may want to note that this one, since the Ka is not that terribly small and this solution is not that strong, you might want to consider subtracting the minus x up here and solving the quadratic formula. It's not necessary, but if you do, it certainly would not be wrong.